Okay, we've all been there, right? You're in the middle of something important. Maybe you're rendering a huge video, or you're in that final boss fight. Heck, maybe you just have 20 browser tabs open. And then, bam, your super fast top-of-the-line machine just crawls. It starts stuttering, lagging. It's beyond frustrating, right? But what if I told you that slowdown, that thing that drives you nuts, is actually the most important feature your computer has?
Yeah, you heard me right. It's not broken, it's not failing. In fact, it's doing the exact opposite. It's fighting, tooth and nail, to save itself from a complete and total meltdown.
So let's get into it. Here's the fundamental problem, right? You've got this tiny little chip, the brain of your computer, doing billions, literally billions of things every single second. And all that work generates a ton of heat in a super tiny space. And if that heat just keeps building up, well, it can actually melt the insides of the chip, like for real. It would just kill your machine, permanently. So it's this constant tug of war between going as fast as possible and not melting down.
So how does your computer possibly win this fight? Well, it's got a secret weapon, or more accurately, a team of 3 secret guardians working behind the scenes 24/7 to keep things from going off the rails. Let's get to know them.
First up, you've got thermal management. Think of this as the general or the mission commander of the whole operation. It has these little spies, these tiny digital thermometers scattered all over the hottest parts of the chip, and it's always watching them. The second things start to get a little toasty, it's the one that gives the order, "All right, time to crank up the fans."
Then there's power gating. This one's the efficiency expert, the smart one on the team. See, your processor isn't just one big block. It's made up of all these different specialized areas. And if you're just, scrolling through social media, you don't need the super powerful graphics part to be running. So power gating just turns it off, completely cuts the power. It's exactly like turning off the lights when you leave a room. It saves a boatload of battery life, sure, but just as important, it stops that part of the chip from making any heat in the first place.
And last, but definitely not least, we have throttling. This is the big red button, the emergency brake. This is the guardian that steps in when things get really serious. When the fans are already blasting at full speed and it's still getting hotter, throttling just slams on the brakes. It intentionally slows the whole processor down, cutting its speed and power. And that immediately brings the temperature down. Now, this is the slowdown you actually feel. It's that frustrating lag, but it's literally sacrificing speed to save the entire computer from dying.
Now, the coolest part is that these 3 guardians aren't just sitting around waiting. They're not separate. They're in this constant, super fast feedback loop. We're talking measure, compare, act. Measure, compare, act. All happening in milliseconds. It's a non-stop dance. Okay, so let's paint a picture. Let's say you're gaming hard, and your processor hits 90 degrees Celsius. Step 1, the thermal manager sees this and goes, whoa, that's getting close to our 95-degree red line. So it immediately cranks the fans to 100%. Maybe it also power gates a few non-essential parts of the chip. But what if the temperature still climbs and hits that 95-degree danger zone? That's when the emergency happens. Bam! Throttling kicks in, slams on the brakes, and cuts the speed. And it'll hold it there until the temperature drops back down to a safe level, say 70 degrees, and only then does it let you go back to full speed.
So when you lay it all out like this, you can really see how it's a team effort, right? Each guardian has a very specific job. Thermal management, its trigger is rising heat, and its goal is just to get rid of it. Power gating, it sees idle parts of the chip, and its goal is just to be more efficient. And throttling, its trigger is that big red line, the safety limit, and its one and only goal is to prevent a meltdown. It's a really clever, multi-layered defense system.
Okay, so that's all the techie stuff happening under the hood, but let's bring it back to you. How does all this invisible magic actually affect what you see and feel when you're using your laptop or your phone?
Well, honestly, this system is kind of everything. Because it works so well, you get longer, more consistent performance. Your fans aren't screaming at you all the time. That crazy good battery life on your laptop? Yep, you can thank power gating for that. And the fact that we can have these mind-bogglingly powerful chips in super thin phones with no fans at all, that's also thanks to this system. The only time you're even aware it exists is when things get too hot and that emergency brake, the throttling, has to kick in and you feel that stutter.
And believe me, the difference between a good and a bad thermal system is night and day. A device with great thermals, it just feels fast, it stays quiet, and it lasts for years. But a machine with poor thermals, it's going to be constantly stuttering, it's going to crash more often, and you're basically just slow cooking the components to an early grave. So yeah, this stuff is absolutely critical for the health of your computer.
But, this whole brilliant system of saving itself,
It's not a free lunch. There are trade-offs. It forces a compromise between the raw power a chip could have and what it can actually do in the real world.
And here's the biggest one. You know that crazy high speed they advertise on the box? That up to 5 gigahertz number? Well, your computer can probably only hit that speed for, like, a few seconds, if it's nice and cool. The instant you start doing real work, those guardians step in and put a cap on it, a performance ceiling, just to keep the heat in check. So that advertised speed, that's kind of the dream. The throttled speed, that's your day-to-day reality.
So here's what I want you to take away from all this. The next time your machine starts to stutter and you feel that flash of anger, take a breath and remember what's happening. It's not a bug. It's not a flaw. It's a feature. It's the system working exactly as it's designed to. It's the price we all pay for having chips so incredibly powerful, they literally have to be protected from themselves.
And that kind of leaves us with a big question, doesn't it? Is all this throttling, this constant self-limitation, just a necessary evil we're stuck with? Or is it actually one of the most brilliant pieces of engineering in the entire tech world?